guys, today we're going to piggyback on what we did yesterday and extend our conditions for parallelograms. So our goal is to determine if a quadrilateral is a parallelogram. And we're going to go through several different theorems or properties that are going to prove that something is a parallelogram. You guys will need to know each of these. So don't get intimidated by all of this. All right, so right here, we're going to start with our definition, a little reminder from yesterday. To say that a quadrilateral is a parallelogram, by definition, again, you need to know the definition, you must show that both pairs of opposite sides are parallel. So your definition of parallelogram is that both sides, or both pairs of opposite sides are parallel. Now, there's several other ways that we can go through and prove that something is a parallelogram. Now, we're not going to be doing proofs. We're going to be using these as reasons. And you guys will see that as we go through some examples. Okay, so just like I was saying the other day, this whole paragraph is summarized in this last statement. So really just focus on that. All right, so we have our definition that we can show where opposite sides are parallel, and then we have 1, 2, 3, 4, 5 other ways. So let's go through each one. If a quadrilateral has a pair of opposite sides that are parallel and congruent, then it is a parallelogram. So look at your drawing here. There's is a quadrilateral, and it shows that one pair of opposite sides is parallel and that same pair is congruent, therefore that's a parallelogram. This differs from your definition because your definition says that both pairs of opposite sides are parallel. So notice the difference between the two. Our second way is that if a quadrilateral with opposite sides are congruent, then it's a parallelogram. So both pairs of opposite sides are congruent. Therefore, quadrilateral ABCD is a parallelogram. If we have a quadrilateral with opposite angles that are congruent, it's a parallelogram. Both pairs of opposite angles are congruent. If we have a quadrilateral with the consecutive angles are supplementary. Remember, guys, consecutive means next to. So angle A and B are consecutive and they're supplementary, and angle A and D are consecutive and they're supplementary. Remember, supplementary add together to equal 180. If a quadrilateral's diagonals bisect each other, so AC is an arrow that pierces through BD, and therefore BZ and ZD are congruent, and BD is an arrow that pierces through segment AC, making AZ congruent to ZC. All right, now one thing to make clear on is that segment BZ is not necessarily congruent to segment AZ. So just watch out for that. Okay, so just to recap, guys, both pairs of opposite sides are parallel. This is your definition. One pair of opposite sides is parallel and congruent. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. One angle is supplementary to both its consecutive angles. So check out one guy. When you go to the right and go to above, they're going to be supplementary to those angles. The diagonals bisect each other. You do not need to know that this is theorem 6-3-5. You need to know what it's telling you. So let's go through and see what some problems are going to look like. For example, when we want to show that polygon JKLM is a parallelogram when A equals 3 and B equals 9. So let's go through, and we're basically just going to crunch a couple numbers, and then we're going to write the reason up. Nothing crazy. So I'm going to plug A in, or 3 in for A, and I end up getting 45 minus 11, which is going to be 34. And then likewise, when I plug 3 in for A over here, I get 34. All right, so I know these guys are congruent. You know what I'm going to tell you. Mark on your drawing to help you out. I'm going to plug 9 in for B, and I end up getting 51. And I plug 9 in for B here, and I get 51. So these guys are congruent. So I know that the length of JK equals the length of LM, which equals 34. And I didn't put a segment over because I'm dealing with length. I know that the length of KL equals the length of JM, which is 51. Let me go back and make sure I didn't make a mistake. Double check your work. So JK, LM, 34, KL, JM, 51. Therefore, I know that JKLM, polygon JKLM, is a parallelogram because opposite sides are what? Both pairs of opposite sides are congruent. And this is all you need to show and all you need to write up. So it's kind of like a little mini algebraic proof. All right, so I want you guys to take a second, pause the tape, and try B. B is going to be your quiz tomorrow. So we're going to show that polygon PQRS is a parallelogram when x is 10 and when y is 6.5. All right, so if I plug 10 in right here for the measure of angle R, I end up getting 134 degrees. When I plug 6.5 in for the measure of angle S, I end up getting 46 degrees. And likewise, when I plug in 6.5 for the measure of angle Q, I also get 46 degrees. Well, when you guys get angles that are consecutive and I have different measures, it's going to be screaming supplementary to you. So 134 plus 46 is in fact going to give me 180. 134 plus 46 is 180. So I know that polygon PQRS is a parallelogram because the angles, well, I'll say this. Consecutive angles are supplementary. So we're using that last property that we talked about. All right, guys, so something similar here. Here are all your reasons that we went through. Now we're not having to plug anything in. We're just checking out our diagram. Well, this is going to be similar. Determine if each quadrilateral must be a parallelogram, okay? Well, I have consecutive angles here. What did I just tell you guys? It's going to be screaming supplementary for you in that last property that we talked about, that last theorem that we talked about. So in this case, the answer is going to be yes. .73 degrees is supplementary to both consecutive angles. All right, consecutive angles are supplementary. Let's look at this one right here, guys. So I feel like the yeses are going to be the easier ones. The no's you have to be careful with. All right, don't put more in than there's there. So let's look at a no. All right, in this case, I have one pair of angles that's congruent. All right, however, this is no. Look at your list here. Why is it no? Because I need two pairs of opposite angles to be congruent. So again, this is where you're going to have to go and memorize or really know these different properties so that you don't get them confused when you're looking at your drawings. And this is what we'll practice on our homework as well. All right, let's go ahead and check out this one here, guys. This one's a little different, so we're going to talk about this last. Let's look at 2B. I have two pairs of congruent sides. However, take a second and look at your list. Why would this be a no? Because I need two pairs of opposite sides. So opposite sides, oops, are not congruent. Okay, so that would be a perfectly fine reason. You guys will just need to communicate to me that you know what the reason is, or not. Now this one here is a little bit different, guys, okay? Don't get outsmarted by this. So, look at 2A. Now, I need opposite angles to be congruent, okay? However, this angle is congruent to this. How can I show that this angle is congruent to this? This does not tell me this is parallel, by the way, okay? So, I'm trying to show that it's parallel. Now, these guys are congruent. I need these whole guys to be congruent. So be careful with that. However, you guys think back in the past, I have 1, 2 angles that are congruent in one triangle. I'm just looking at this triangle right here. Therefore, I can say that this angle is congruent to this angle. Do you guys remember? By your third angle theorem. Now, if this is congruent to this is congruent to this, I know this guy is congruent to this guy here. So yes, this is going to be a parallelogram because of the fact that this reason right here. 2 pair of opposite angles, or I should say this guy right here. 2 pairs of opposite angles are congruent. Okay, so this one had a couple layers to it, and you guys may expect to see that in your homework and in your notes, or your homework and in your quiz potentially. All right? We'll work on our homework tomorrow, guys, and that's all we got.